Modern airplane can weigh over 600 tons and still fly without any problem in the sky. In this video we will see how such a heavy plane lifts off the ground and fly through air so easily. When airplane is flying in the air, there are four forces acting on the airplane. These are weight of the airplane. The weight of airplane is a force that acts vertically downwards due to gravity. If this force is not balanced by an equal and opposite force acting vertically upwards, the airplane will fall. This force acting vertically upwards is called lift. The lift is generated by the wings of an airplane. Drag. The air resists the motion of the aircraft in forward direction and the resistance force is called drag. To overcome drag, airplane uses a propulsion system to generate a force called thrust, which keeps moving the plane in forward direction. The thrust in this case is provided by the turbine engine below the wings, which works on Newton's third law. It pushes air in backward direction with great force, and as a result, air provides reaction force to the airplane in forward direction. In a turbine engine, a fan at front sucks the cold air in. The majority of this air is directly pushed out of the engine and generate pure thrust. Some of the air goes into second fan called compressor. The compressor squeezes the air that enters into progressively smaller areas. Just behind the compressor, in combustion chamber, air is mixed with fuel and then ignited. The exhaust gases rush past a set of turbine blades, causing it to spin. The turbines are linked by a shaft to turn the blades in the compressor and to spin the intake fan at the front. The exhaust gases before going into atmosphere passes through a nozzle where the exhaust gases accelerates backward and the engine and aircraft are thrust forward. There are many theories of how lift is generated. In fact, it is very controversial and often poorly explained. One of the widely circulated incorrect explanation of lift is given by applying Bernoulli's theorem incorrectly. The theory states that airfoil are shaped with the upper surface longer than the bottom. Since the molecules going over top of the wing has to travel along longer path, it must travel faster than the molecules moving under the wing, so that they can meet again at the trailing edge at the same time. According to Bernoulli's theorem, if potential energy is neglected, the total energy of fluid is shared between its kinetic energy and pressure energy, and remains constant during the flow. Because the upper flow is faster, then from Bernoulli's equation the pressure is lower, so that total energy remains the same. The difference in pressure across airfoil produces the lift. Although this theory seems to be reasonable, there are some flaws in this theory. Experiments shows that the flow is much faster over the top of the airfoil than the speed required to have the molecules meet up at the trailing edge. And the non-physical assumption made in the theory that molecules meet at the trailing edge is found to be wrong. Thus, lift predicted by the equal transit theory is much less than the observed lift, because the velocity on the top of the wing is much higher than estimated by this theory. Also, it is not necessary for lifting airfoil to have upper surface longer than the bottom. It is perfectly possible to design planes with airfoil that are symmetrical and still produce lift. For example, paper planes generate lift even though they have flat wings. This is because by keeping the symmetrical wing at an angle, we still get air flowing at relatively higher velocity on upper surface. So angle of attack is more important than the shape of airfoil. This theory also says nothing about turning the flow down. As we can see in this case, the incoming air velocity and outgoing air velocity are same as it passes through the wing, and hence there is no acceleration of air molecules. Therefore, according to Newton's second law, there is no net force acting on the air molecules. And if no force has been applied on air molecules by the wings, air molecules cannot provide any reaction force to the wings, and hence there will be no lift as it violates Newton's second law. Therefore, if these points in theory are reconsidered, Bernoulli's theorem explains the lift correctly. Another way of explaining the lift is by using Newton's law. After passing through the wing, the air does not follow a straight horizontal path, instead it is deflected down. According to Newton's second law, the only way to change the velocity of an object is to apply force. Thus, this change in flow direction requires a downward force applied to the air by the airfoil. Then, according to Newton's third law, the air must exert an upward reaction force on the airfoil, and thus lift is generated. The downturning of the flow is not produced solely by the lower surface of the airfoil, and the airflow above the airfoil accounts for much of the downward turning action. Since both the surfaces are involved in deflecting the flow downward, more air is reflected down and thus more lift is generated. Instead of being correct, this theory does not provide any detail about how the turning of flow is taking place over the wing. It simply says that because the flow is turning down, the airplane must be pushed up. Both Bernoulli's as well as Newton's explanation are simplified physical explanation of lift. The real details of how an object generates lift are very complex and do not lend themselves to simplification. To predict lift requires solving the equation for a particular airfoil shape and flow condition, which generally requires calculations that are so voluminous that they are practical only on a computer.